A good segue. So when we use tools like ChatGPT, so if you open ChatGPT, this is what you're gonna see, right? You probably see a slightly different interface depends on the subscription level you have. You are given this prompt box, and you of course have different depending on the subscription level you have. You will get different functions as that you can choose. Um, and the response time will be different based on your service level. Um, so what you do here is that, well, no matter what you use, ChatGPT or DeepSeek, you are given this box, and you're going to put in some text, for example, and that text is the prompt. So the prompt is how you initiate a conversation with this model or any model. But from that point on, you basically have an interaction with the model. And if you don't want to do any sort of augmentation or update or fine tuning later, you basically can use the model as is. I think majority of the users will be using the model in such a way. You give the prompt, you get the results back. And of course, to this, this today we're gonna see some programming examples, and later on we're gonna use more advanced techniques to fine tune the model and augment the model with new information. Those later tasks will have a lot of programming aspect to it. So what we do in this course is we're going to cover these different type of approaches to use the model or optimize the model. First, the experiment and select. So this is what we're going to talk about today, primarily. We're going to see different ways or the best practices of you using prompts to interact with this model, and how we can use so-called in-context learning to kind of find a way to give new information to the model without writing a program to train the model or fine-tune the model or augment the model. So the first part, experiment select, is really just typing some prompt or you organize your prompt in a way that you can get the desired result as accurate as possible. On top of that, if you want to use the model to solve a particular domain-specific problem, you will oftentimes need fine-tuning. And there are different ways to do fine-tuning using so-called parameter efficient fine-tuning or using reinforcement learning with human feedback. That's our LHF stands for. That's what we consider as adapt, align, and augment. So those are the techniques we will talk about today, where a lot more of coding will be involved. The other part of the materials we're going to cover is the evaluation. So how do we compare the models? Like the paper that I was referring earlier, DeepSeek R1, in the technical report, and many other researchers report, when they compare models, they have specific data set methodologies to evaluate them. That's what we call benchmarking. And we're going to talk about that too. And the fourth part is the deploy and integrate. This will involve a lot of the kind of quantization, containerization, pruning techniques so that we can efficiently deploy your own model in a certain environment. So we're going to have some discussions on that too. So if we put these in the project life cycle, you can see that we have a few steps. We can probably start the low coding case of experiment and select, and gradually we can change the model through fine tuning, and then we can evaluate them. And for the production level deployment, let's say you are running a company, you have this model you want to provide as a service to the user, then we have to look at how we deploy that, and also relevant tools, for example, monitoring to see how the model is doing and whether we need to do some improvement maintenance. Okay, so what kind of prompts? You probably use some of them. So the text-based input prompt is what you typically will use to interact with the model, and the model will respond with a completion. This completion could be different modality. If you, for example, ChatGPT, you can choose to ask it to generate a text response. That's by default, or an image, or audio or video. So you could be getting different type of modality of completions. So these are the example prompts. You can say, okay, summarize the following text. You can then put in the whole text, or you can upload a PDF document and say summarize the content from this PDF file. Or you can ask who won the baseball World Series in 2024. Or you can say I want to generate image of 4 people in a meeting using with MacBook computers. So they will so image will be generated. So when we talk about text response, we often use the word tokens. And when we talk about the capabilities of different models, they also include specifications on these tokens. So they can say, okay, what is the max input token or max output token? So what is a token? If you have this question, who won the baseball World Series in 2024? As a human, if you know English, you will be able to break down these sentences into small words, and you know the meaning of these words, and you can come up with the meanings of this whole sentence. And if you want a computer to understand this, so that will be a natural language processing tool that can maybe translate this to a different language. So that's what we're talking about, natural language sentences. But for the generative AI model, for the large language model to understand your input, your prompt, these prompt text sentences actually are broken into, we call it tokens. So smaller pieces of units that will be fed into this large language models. Tokens kind of similar to words, English words, but it's not exact English words. So on average, you are talking about 1.3 tokens per word. So tokens are smaller unit than word. That's the rule of thumb. And the text inputs are tokenized. So it will be converted into a sequence of tokens using a method that we'll talk about. But you can now assuming that whatever text input you are putting into will be tokenized. So it will be small chunks that will be taken as an input to the large language model. So that's the input side. The output side is the reverse of it, in the sense that the generative AI model, large language model, will give you the output, will give you a response. But from the model, in fact, it generates a sequence of tokens. So not the word itself, but the tokens will be later kind of mapped back to the words using a reverse process. We're going to look in more detail about tokens next week. But for now, you can think about this. Tokens are small units that these natural language sentences will be broken into, and also as the output side, these tokens will be then reverted back to the words in the original like English dictionary. Okay, so what do I mean by prompt engineering? Here's an example. If you just put in this question into a chat GPT box, well, it depends on the version of the model you use. You can actually choose O4 or O1 or different models from OpenAI. Or if you choose DeepSeek, you can also choose different versions of models from that company. So generally you don't expect a model to give you the same output, i.e. the completion. Even let's say you use the same model, you ask it twice, there's no guarantee that you get the same answer because the generation is a stochastic process. So it's natural, it's reasonable that you will see different answers. And if you use the same prompt across different models, then of course the output will be also different, most likely. But let's say we give this prompt and then in some models are very chatty. So this is one possible output, a completion from a model. So give you the answer. Okay, Los Angeles Dodgers won the 2024 World Series, defending New York Yankees in a 4-1 series. And in Game 5, Dodgers made a historical comeback, rallying from a 5-0 deficit to win 7-6, and so on. If you are happy with this, detailed information with some commentary, that's probably okay. But let's say, I don't have time. I just want to get a straight answer. Or maybe I want that answer to be, put into my other document. I can then later process or to my database. So I don't need this very chatty output. So now, but at the same time, I don't want to fine tune this chat GPT model, which I probably won't be able to because it's closed source. So how do we do something in the prompt? Can we tweak the prompt in a way that the completion will be closer to what I'm expecting to get? So that's what the prompt engineering is about. All right, so we'll start with this 5 principles of prompting. You want to design your prompt so that you will be able to get the desired result. These are the 5 principles you will need to consider, and we'll try to give examples for each of them. First, give direction. You want to give the desired style in detail. We'll see some examples of that. And you can specify format so that you will let the model know this will be the structure of the response I want to receive. For example, sometimes I want to have a specific format as an output so that I can take to my other Python program. So JSON format is a very widely used data structure that can pass information cross-platform and cross-language. So JSON is often the time that a preferred format if you want to have a structured response. So you can say that. And the third one is to provide examples. You can insert a diverse set of test cases where task was done correctly to show that, okay, this is where I would expect the model to produce the result. Then you can evaluate the quality. There are different ways to do that. Manual case, manually, you can also do more a systematic way. And the last one is divide labor to split tasks into multiple steps. So let's see how we can give more direct or detailed direction. So in this example, I want to generate a new name for a shoe that fits any foot size in the style of Elon Musk. So Elon Musk has this, SpaceX, Tesla, this, different naming kind of styles. So what I have here as the prompt is that I say very specifically, return the result as a comma separate list in this format. The product description, a shoe, sorry, the typo here, that fits any foot size. The product names, will have three candidate names. And I gave some examples. For example, so a refrigerator that dispenses beer, so have product names. So this is the example output. Tesla Cool, Fridge X, Neura Drink. Another example is a watch that can tell accurate timing in space. So I'll be the possible names of SpaceX, iSpace, the watch company. So these are kind of the examples, and I also specifically say that I want to have these product names. All right, so if you compare, so the output will likely be something like Shoe X, Mars Fit, the shoe company. You can see that these three product names, if you look at the product is a shoe that fits any foot, it fits the purpose very well. Also, it gives you the Elon Musk style. So if you don't have these specific instructions, let's say if you don't have in the style of Elon Musk, if you don't have these examples, you probably won't have these exact output that you would like to have. So this is a very simple example. Of course, you notice that, but this demonstrates that how you can structure your prompt so that you can get the exact output you would like to have. Also, you can do some sort of so-called pre-warming or internal retrieval. This example is to show how we can come up with a few prompts that can help us get the final output. And this is called pre-warming. So let's see what we have doing here. So the first input is that please give me 5 tips for naming products based on expert industry advice. So if the model is knowledgeable, it has training data about this industry, otherwise it will give you some list, the how to name a product. So this model responds, there are 5 expert tips to guide you on naming product, simplicity and memorability, and positive connotations, etc. So you have a list of these tips that list here as first completion. You know that you can keep asking questions, and these questions are organized in the same chat window we call the context. So in this same chat window, you can follow up with a new question with a new prompt saying, use this device. I have a list of product names for a pair of shoes that can fit any foot size. So this is an example of so-called pre-warming. So you can prompt the model to give you a list of guidelines, and then you can say, okay, follow these guidelines. Can I have a list of the product names? Okay, about format, as I mentioned that JSON is the most popular, I would say, structured data format that can be used across platforms. So for this one, I want a comma separate list of product names in JSON format for a pair of shoes that can fit any foot size. And I say return only JSON. And so I also include an example. This example of product description, home milkshake maker, and product names will be these four examples. And the second example is a watch that can tell accurate time and space, and I have some examples. Then the output will take into consideration your specific format and also how you structure these outputs by using two keys. One is product description and one is the product name. And for product name, it's actually a list of names, four names here. So this is one good example of how you can specify to set the output as JSON format. For pictures, images, or even videos, you can also add these format specifications. So I want to generate a meeting of picture of people in a business meeting. I can say in Van Gogh style. So this picture was generated by ChatGPT, and the same picture, but in a different style. This is the Minecraft style was generated. So you can see they did these pretty well. You can try these prompts in ChatGPT or Canva, which is another tool that is capable of doing text to image generation. Actually, it was interesting to play with this text to image generation function in ChatGPT. It does these generation jobs good in some cases, but if you try to give it a specific instruction, I don't feel that it was able to generate these images as you asked. For example, let's say at one time I want to generate a family picture with a small baby girl with grandparents and parents and a bigger sister. Man, was so hard. It generated either missing the grandparents or missing the big sister, or it's just not the ones that I would like to see. So there's a lot of the imperfections still there. So I encourage you to try a few examples in these tools. Speaking of examples, we actually saw earlier example that we add these examples as a part of the prompt so that the model can know well what they expect output from that prompt. Right. So evaluation of quality. One of the things that you do as kind of exercise is to, for example, you can type in the text to image prompt and hopefully to generate a picture. Or you can, you just try a few examples to generate names of your shoe company, products of the name of the products. You can sit there and evaluate each of these outputs to see, okay, is this, a good one or bad one or, mediocre one. But if you want to rigorously evaluate a model or compare it with other models, you need to have these well-known or well-recognized benchmark. For example, I think when ChatGPT was released last year, the new version, they used the bar exam as an example to show how the ChatGPT can answer the questions in the bar exam. And similarly, in this DeepSeek R1 paper, they include a benchmarking result. This is the one I was going to show you. Okay, fortunately, I have it here. So this is the how they typically compare different models. Different bars representing different models. So the first one is DeepSeek R1, and then it compares with OpenAI's O1 model, which is a reasoning model, and this is the R1-32B, and then this is the O1 Mini, and also DeepSeek V3. So these are models that are included in this comparison. And for each group, so we have a benchmark. For example, this AIME 2024, this is actually a very well-known mathematics competition. If you search Google search, you'll find that every year they have this mathematics competition problem set. And in this case, they solve these math problems and to then score them. And you can see that the DeepSeek R1 is better than the OpenAI's O1 model. And Code Force is a programming contest. So there are programming questions. And these models are trying to produce answers and then compare the correctness and effectiveness of these solutions to those programming questions. I think DeepSeek is almost the same, if not better, than the OpenAI's O1 model. And this Math 500 is another set of mathematical questions. And then MMLU is it's more about the knowledge, generation, knowledge learning. And SWE is the software engineering benchmark group. So they compare it really to look at how these models can be generalized in different applications, solving mathematical questions, programming contests, and also software engineering tasks. So we will talk more about the model evaluation, but this is a good example that shows you how people are using these standard benchmarks to compare the performance. All right, here's a list of the benchmarks that we saw earlier. AIME is a math competition for students who excel on AMC 10 or AMC 12. There are other, so MMLU is basically I call the knowledge group, so that evaluates the model's general knowledge and problem solving abilities across 57 subjects: elementary, math, US history, computer science, and law. Okay, divide labor. This is to basically decompose the bigger task into small parts to solve simpler problems and then re-aggregate the results. For example, for the shoe names example, we can first generate shoe names, and then based on the generated shoe names, then we can evaluate the quality of names based on certain criteria. Yeah, so this is a divided labor.